Hello everyone and welcome. In this video, we are going to learn about logic circuits and truth tables. This topic is a very important part of O-level computer science because it helps us understand how computers think and make decisions. Let's start with Boolean logic. Boolean logic works with only two values, 0 and 1. 0 represents false and 1 represents true. Even though this system looks very simple, it is the basic language used by computers and electronic devices. Why Boolean logic is used? Computers do not understand words or emotions, they only understand on and off signals. That's why Boolean logic is used in computers and electronic circuits, which is to process information and control different operations. Now let's talk about logic gates. Logic gates are small electronic circuits. They take inputs in the form of 0 or 1, or they produce one output which is also 0 or 1. Each logic gate follows a specific rule. When we connect multiple logic gates together, they form a logic circuit. Logic circuits are used to perform specific tasks, such as making decisions, checking conditions, and controlling systems inside a computer. To understand how a logic gate works, we use something called the truth table. The truth table shows all possible input combinations and output for each combination. This makes it easier to predict the behavior of a gate or a circuit. Now we will talk about the NOT gate. The NOT gate has only one input. Its job is very simple. It reverses the input. If the input is 1, the output becomes 0. If the input is 0, the output becomes 1. Because of this, the NOT gate is also called an inverter. The next gate is the AND gate. The AND gate has two or more inputs. The output is 1 only when all the inputs are 1. Even one input is 0, the output becomes 0. You can think of it like a security system. All conditions must be true for the system to work. Now let's look at the OR gate. The OR gate also has two or more inputs. The output becomes 1 if at least one input is 1. The output is 0 only when all the inputs are 0. For example, a bell rings if any one button is pressed. The NAND gate is a combination of an AND gate and followed by a NOT gate. This means its output is the opposite of an AND gate. The output is 0 only when all the inputs are 1. In every other case, the output is 1. The NOR gate is a combination of OR gate and a NOT gate. Its output is 1 only when all the inputs are 0. If any input is 1, the output becomes 0. Finally, we have the XOR gate. The XOR gate gives an output of 1 when the inputs are different. If both inputs are same, either 0 or 1, the output becomes 0. An easy way to remember this is one input on and the other off. And that brings us to the end of this lesson. Take some time to practice truth tables and logic gates because they are very important for understanding digital systems and for doing well in exams. Thank you for watching.